Okay, so in this video, we're looking at proving that quadrilaterals are parallelograms. Last class, we learned about if a quadrilateral was a parallelogram. I told you that. And then I told you about the four properties, things that you knew if you knew it was a parallelogram. Now we're working backwards. We're looking at the biconditional, right? We're looking at, if I give you a little piece of information, can you tell me from that information, is it enough information to say that the shape is a parallelogram? And therefore, all the properties will apply as well. So it's taking a little bit of information and finding more information. What can you do with that information? So what we see here are our 6 methods. There are 6 methods here, and they relate back to the properties. So here, method 1 is the definition of a parallelogram. Method 2 is one of the properties, finding that opposite sides are congruent. Method 3 is proving that the opposite angles are congruent. Method 4 is the third property, prove an angle is supplementary with both consecutive angles. Method 5 is property 4, prove both diagonals bisect each other. And method 6 is a new method. It's a combination of method 1 and method 2. You find one set of sides that are both parallel and congruent. The same set. It has to be the same set. So take a minute, pause the video if you need to, but write down these 6 methods, and when you're ready, restart. And we're going to look at some properties. We'll look at some examples. Alright, so this first example is to prove that 2 sets of parallel sides. Well, that could just be as easy as both of these sets being marked as parallel. Or, here's an alternative way, is if they give you alternate interior angles, right? And then you use that to prove that there are 2 sets of parallel sides. Now there you want to be careful that your alternate interior angles actually prove 2 different sets. You wouldn't want your parallel sides, your alternate interior angles, to be proving the same set of sides as parallel. So make sure that you're doing your due diligence in proving 2 different sets. Okay, so here's 2 different examples of proving that 2 sets of sides are parallel. These would both be method 1. Method 2 asks you to prove that opposite sides are congruent. So you would need something that looks like this. This is an example of 2 sets of opposite sides congruent. Method 2. Method 3 would be prove 2 sets of opposite angles congruent. So if this angle was a given value and the opposite angle was the same given value, then that would be opposite. But that wouldn't be enough. You would also have to prove that this angle and this angle are also congruent to each other. These 2 angles have to be congruent with the first 2 sets. And that would be method 3. Method 4 is to prove, let's say this is 100 degrees. You would have to have these 2 and these 2 adding up to 180 degrees. And that would give you one angle supplementary to both consecutives. Alright, so that would be method number 4. Method number 5 is to prove that the diagonals bisect each other. So, a little hard to speak. Okay, prove that both diagonals bisect. Now these things that I'm writing here are your reasons, right? Your justifications. You need to be able to explain when you're looking at a picture, you're going to be saying yes, it is a parallelogram, or no, it's not a parallelogram. And you can't just guess. You can't just say, oh, yes, no. You have to say yes, because both diagonals bisect, or no, not enough information. All right, so we've done 5 methods so far. Here's our 6th method. Maybe I just give you one side is parallel and congruent. You'd say, oh, okay, one set of opposite sides, parallel and congruent. And that'd be enough. Well, perhaps it could be a little trickier, and they'll give you alternate interior. All right? Let's say there are alternate interior angles that are congruent. And so that's enough to get you a set of parallel sides. And then let's say that I also told you that they were congruent. But again, whenever we start messing with alternate interior angles, you want to make sure that we're talking about the appropriate sides. You want to follow this path. Make sure that you understand which sides are parallel. Otherwise, you don't want to make a mistake and call the wrong sides parallel. Again, this is method 6. One set of opposite sides, parallel and congruent. Those are your 6 methods. And so when you come back, we're going to be practicing those. We're going to give you lots of examples of pictures, and you're going to look at what properties you see and tell me, is that an appropriate property? Is there enough information to say, yes, it's a parallelogram because of property A, 1, 2, 3, whatever property I give you, or no, there's not enough information. Okay, on the back here, we can do this also on a coordinate plane. And here you're going to have to do a little bit more math and arithmetic to be able to figure this out. So again, pause the video and go ahead and write down this box. Fill out this box to the best of your ability, and then we'll move on. So pause the video while you fill it out, and then restart the video when you're ready. And now we're going to look down here at some examples. So here are the points that I want you to work with for all 4 of these problems. Okay? So plot those points like I did here, A, B, C, D. Each of these will be plotted the same, so you have the same picture on all 4. We're going to look at 4 different methods, right? Of the 6 methods, only 4 can be done on the coordinate plane. One method that can be done is to prove parallel sides. So if you want to prove parallel sides, you need to prove to me that this is parallel to this. Prove AB is parallel to DC, right? So find the slope of AB. Find the slope of DC. Once that works out, you should then find AD parallel to BC. So again, you're finding the slope of AD, you're finding the slope of BC. And I'll allow you to figure that out. You have the formulas, you should be able to find slope. Make sure that your slopes are the same. That's how you prove they're parallel. Slope AB is the same as slope DC. Slope AD is the same as slope BC. You need to figure that out and let me know if it's a parallelogram or not. Method 2 would be to prove 2 sets of congruent sides. So in order to do that, you're going to need the distance formula. You're going to tell me, is AB equal to DC? So tell me how long AB is. Tell me how long DC is. Once you've proven that, you'll then have to prove that AD is congruent to BC. right? If we're talking about congruency, then you'll need to write it that way. AD is equal to what, and BC is equal to what? Again, use the distance formula to prove that those opposite sides are congruent. Method 4 is to prove that the diagonals bisect. So if they're going to bisect, that means they're going to meet in the middle. They're going to meet at the midpoint. Both points would be at the midpoint. So if we're looking at this A, B, C, D, right? First diagonal would be AC, so find its midpoint. Midpoint of AC. Find the midpoint of DB. Once you find those two midpoints, they should be the same. If they're not the same, then they are not bisecting each other because they're not meeting in the middle. Okay, last method that you'll do is to prove one set of sides is parallel and congruent. So pick a set, doesn't matter. Let's say AB congruent to DC. Then you'd also have to prove that AB is parallel to DC. Has to be the same two sides that are both congruent and parallel. Which order you do that in does not matter. But tell me, how long is AB? How long is DC? Right? Tell me the slope of AB. Tell me the slope of DC. Once you calculate those, you should be able to check off whether or not it's true or false. So, practice those. I expect you to bring this in and have any questions and be ready to work on some problems in class.